The open systems interconnection model was developing starting in the late 1970s to support the emergence of the device-computer networking methods that were computing for application in the large national networking efforts in France, the United Kingdom, and the United States. The model partitions the flow of data in a communication system into 7 abstraction layers. From is a physical implementation or transmission bits across a communication medium to the highest level partition or of data of a distributed application. Internet protocol suite is the central model and the set of communication protocols used in the Internet and similar computer networks. It is commonly known as TCP and IP because the foundational protocols in the suite are the transmission control protocol and the international protocols. The Internet Protocol Suite provides end-to-end data communication, specified how data should be packaged, addressed, transmitted, routed, and revised. This functionality is organized into 4 abstraction layers with classify all related protocols according to the scope of networking involved.
What is network architecture? In general, architecture is the art and science of designing and constructing, or the discipline dealing with the principles of decision and building. The term architecture means the formation of a structure or an orderly, interconnected, complex arrangement of parts. An architecture encompasses hardware, software, data link controls, standards, topologies, and protocols. Network architecture describes relationships between components. Network decision usually specifies technologies, protocols, and network devices. Architecture and the decision complement each other. Another way that architecture can differ from decision is in the need for location information. Location is important for some parts of the architecture, for example, external interfaces, locations of existing devices and applications. Relationships between components are generally location independent. And technical decision of the network solves the application of high-level decision principles to the network building blocks. Building blocks might be viewed as physical entities, routers, switches, multiplexers, servers in the network, or functional entities instead of physical entities. In doing so, the set of high-level decision principles that constitutes the network architecture is applied to how the network functions and operates. OSI model have 7 layers. Application layer, where the application using the network resides. Common network applications include web browsing, file transfers, and remote logins. Presentation layer performs a series of miscellaneous functions necessary for presenting the data package properly to the sender or receiver. Session layer responsible for establishing sessions between users, manages a session by initiating and the opening and the closing of sessions between end-user application processes. Transport layer provides an end-to-end error-free network connection. Make sure the data arrives at the destination exactly as it left the source. Network layer responsible for creating, maintaining, and ending network connections. Transfers a data packet from node to node within and between networks. Data link layer responsible for taking the data and transforming it into a frame with header control and address information and error detection code. Physical layer handles the transmission of bits over a communication channel, includes voltage levels, connectors, media choice, modulation techniques, major capability of that network. Four functions are the major capabilities of network. Addressing routing provides robust and flexible connectivity between devices. Network management provides monitoring, configuring, and troubleshooting for the network. Performance provides network resource to support requirements for capacity. Security restricts unauthorized access, usage, and visibility with the network to reduce the threat and the effects of attacks. Other general functions such as infrastructure and storage.